The illusion of the endless night. Look up at the night sky. It feels like an eternal, unchanging canvas. We grow up believing that the stars will always be there, burning silently in the dark. But modern astrophysics tells a much more haunting story. Our universe is dying. Take our home, the Milky Way galaxy, a majestic spiral spanning roughly 200,000 light years in diameter, housing up to 400 billion stars. It feels alive, yet it is functionally sterile. How many new stars do you think are born here each year? Millions? Thousands? The actual number is just about 3. 3 single stars per year. The heartbreaking reality is that 95% of all the stars that will ever exist in the history of the cosmos have already been born. We are living at the absolute tail end of the cosmic age of star formation. The universe has already peaked, and we are witnessing the very beginning of the end. The shrinking neighborhood. As star formation grinds to a halt, space itself is actively tearing us away from everything else. The Milky Way does not drift alone. It belongs to a cosmic family known as the Local Group. This is a collection of over $50 dwarf galaxies, alongside giant neighbors like the Andromeda galaxy, stretching across a region roughly $10 million light years wide. Zoom out further, and you will find that our neighborhood is just a tiny thread in the Laniakea supercluster, a massive web of hundreds of galaxy groups. In total, the observable universe contains an estimated $2 trillion individual galaxies. It sounds limitless. Yet, even if we invented a spacecraft today that could travel at the ultimate speed limit of the universe, the speed of light, $299, 792 \m/$, about $94 those $2 trillion galaxies are already forever out of our reach. They are gone, and no amount of human ingenuity will ever bring them back.
The ghost of cosmic inflation. To understand why we are trapped, we have to look back to the moment creation began, the Big Bang. Approximately 13.8 billion years ago, the universe emerged from an infinitely hot, dense point. At a fraction of a second, specifically 1 undecillionth seconds after the beginning, the young universe experienced a violent growth spurt called cosmic inflation. In less than a trillionth of a second, space expanded exponentially from a subatomic speck to a scale of trillions of kilometers. But the primordial energy was not perfectly smooth. Tiny, subatomic ripples in density existed. Inflation took these microscopic quantum fluctuations and stretched them across cosmic distances. The areas with a fraction more energy became dense pockets of matter, while the emptier spaces became vast cosmic voids. This uneven distribution is the only reason galaxies exist today. The triumph of the dark force. Following that brief epoch of hyperexpansion, a cosmic tug-of-war began. Inside the high-density pockets, gravity won the battle. Over billions of years, it pulled gas and dust together to forge the stars, galaxies, and clusters we see today. The local group is our specific, gravitationally bound pocket. However, on a grander scale, outside our immediate neighborhood, the expansion of the universe never actually stopped. In fact, it is doing something far worse. It is accelerating. Astronomers attribute this runaway expansion to a mysterious, repulsive pressure known as dark energy, which makes up roughly 68.3% of the entire universe. Dark energy acts like an invisible anti-gravity grid, pushing isolated galactic pockets away from one another at an ever-increasing rate. The gaps between our home and the rest of the universe are widening by the millisecond.
the cosmological event horizon. Because this expansion is accelerating, a terrifying boundary is formed around us, the cosmological horizon. Think of it as a black hole's event horizon, but inverted, wrapping completely around our region of space. Beyond this invisible line, the fabric of space itself is expanding away from us faster than the speed of light. Albert Einstein's theory of relativity states that nothing can travel through space faster than light, but space itself can expand at any speed it wants. Consequently, any object that crosses this cosmic horizon is instantly cut off from us. It is irretrievably lost to the void. We can never visit it. We can never send a radio signal to it, and we can never interact with it again. Tragically, 94% of the galaxies we see in our deepest telescope images have already crossed this line. Looking into the ancient past, this raises a profound question. If these galaxies are already fundamentally unreachable, why can we still see them? The answer lies in the nature of light. Light is fast, but it is not instantaneous. It takes time to travel across the vast gulfs of interstellar space. When we look at a galaxy located billions of light years away, we are not seeing it as it exists right now in the year 2026. We are looking at a snapshot of its ancient history, captured when that galaxy was much closer to Earth. The photons hitting our telescopes today left their source billions of years ago. The observable universe is essentially a cosmic cinema, playing a beautiful, grand illusion. It shows us brilliant stellar cities that, in the present moment, have already vanished into the invisible dark.
The slow fading of the stars. Currently, our observable universe appears to be growing because ancient light from the deep cosmos is still arriving at our doorsteps for the first time. But this is temporary. Every single tick of the clock, the invisible horizon claims more territory. Mathematically, every second that passes, roughly 60,000 stars slip past the cosmological boundary. In the time it takes to watch a short video, millions of suns are swept into the permanently unreachable zone. Eventually, every single galaxy pocket outside of our local group will cross this threshold. When they do, their light will stretch out, red-shifting into oblivion until they completely fade away. The sky will systematically grow darker, leaving our immediate galactic family completely marooned in an empty, cold desert of space. The limits of humanity. What about the remaining 6% of the universe? This represents our absolute physical limit, a sphere of space spanning roughly 18 billion light years. The galaxies within this zone are moving away, but slowly enough that a highly advanced civilization could theoretically catch up to them. But the clock is ticking loudly. Even for a super advanced, Type 3 interstellar civilization, the logistics are mind-boggling. Traveling to the Maffei group, the absolute closest cluster outside our own, would require an 11 million year journey moving at the speed of light. If a future human diaspora attempted this, the crew would become a completely isolated species, separated from Earth forever by a growing wall of empty space. Realistically, humanity will never leave the local group. Our entire future is confined to our immediate cosmic backyard, which represents a mere 0.00000000001% of the total universe.
The birth of Milkdromeda. As dark energy isolates our local group from the rest of the cosmos, gravity will tighten its grip inside our pocket. In about 4.5 billion years, the Milky Way and the Andromeda galaxy will violently collide. They will dance through each other, tearing apart old star systems and compressing massive clouds of hydrogen gas. This galactic smash-up will trigger a brilliant, final renaissance of star formation. igniting millions of vibrant new suns. Eventually, over billions of more years, all the galaxies of the local group will merge into one single, colossal, hyperdense elliptical galaxy. Scientists call this future megastructure Milkdromeda. It will be a sprawling island of 1 trillion stars, packed tightly together, glowing defiantly against an increasingly empty and hostile external universe. The Island of Darkness. Fast forward tens of billions of years into the deep future. The expansion of space has pushed all other galaxies so far away that they are completely undetectable. Imagine being an intelligent creature born inside Milkdromeda in that distant era. Your scientists look out through advanced telescopes, but they see absolutely nothing. No distant galaxies, no cosmic microwave background radiation, and no evidence of a Big Bang. To them, the universe will appear static, cold, eternal, and entirely empty except for their own galaxy. They will never know the rich cosmic history that we can see today. We are incredibly fortunate to live at this exact cosmic sweet spot in time. We are close enough to the beginning to see our past, yet still connected enough to map our future. The cosmos is closing its doors, but for now, the view is spectacular.